Well, welcome back to the FIBO Data Model training. This is Jürgen, and here is part 2 of Semantics for Data Architects. Make sure you watched part 1, which sets the state about the FIB-DM origins, the FIBO ontology, and the transformation considerations. So part 2 is about the data model structure. And here in this lesson, we look at the packages or subject areas, base and associative entities, relationships, the FIBO documentation transformed into the data model, design patterns for semantic models, and consideration when you scope and generate logical and physical models from FIB-DM. Yeah, so this is what we see when we open the model in PowerDesigner. In the first one, every quarterly FIB-DM release has a diagram of the base packages. No? So here we see the generic packages, in particular OMG Commons, language, countries, currencies, and then here the FIBO foundations, loans, securities, derivatives, and so on. And you can open the base packages diagram, and then here we see the main folders. So there are 11 FIBO folders, and here is OMG Commons. And now OMG Commons has a two-level hierarchy. So we have OMG Commons and then the individual ontologies. And the leaf level, the lowest level in the package hierarchy, that is an individual ontology. So here business authorizations was released with OMG Commons 1.3 in December last year, and it is included here in the January release. So there we have a diagram, and for the FIBO has a three-level hierarchy. So if we look at loans and mortgages, we see loans general, loan specific, real estate loans, and under loan specific. Here we see the individual FIBO ontologies, cards, commercial loans, student loans, and so on. So again, lowest level in the hierarchy is an individual FIBO OMG ontology. OMG Commons has 2 levels, the FIBO has 3 levels. Okay, let's look at the package folder structure. So here on the right-hand side, we see the FIB-DM package hierarchy, and we can see that it's identical to, on the left-hand side, the unzipped FIBO download from the EDM Council website. And it's also it's identical to the folder structure, as well as the folders on the URI. No? So here we see FIBO, loan specific, card accounts, and in FIB-DM we have the major root packages for the FIBO subject areas, and then we see loans and mortgage, loan specific, and here the individual specific types of loans. And the ontology prefix is an abbreviation defined in the FIBO. So here, for example, for card accounts, we see that this URI here is abbreviated as FIBO loan SPC CRD. And it's not shown here on the screenshot, but that is also the physical name for the data model package. And then the logical name is simply an uncaml. No? So we take the ontology name and uncaml, basically inserting the space here. So some more detail about the package diagrams, which depict dependencies between the package. Now, the folder structure simply specifies where ontology or data model objects are located, whereas the package diagram shows the dependencies. So the arrows derived from FIBO, OMG, OWL imports and from supertype subtype relations among FIB-DM entities. And before we looked at the loans ontology, which imports FIBO Foundation business entities and finance business and commerce. And the loan entity actually is a subtype of the credit agreement defined in FBC, finance, business and commerce. And loans and mortgages package diagram shows 3 mid-level packages: loans general, loan specific and real estate loans, and 6 leaf-level packages for loans in general and the specific types of loans: commercial loans, consumer, student, and card accounts. Just a note about packages versus subject areas. On the left-hand side here, we see a PowerDesigner screenshot with the data model packages. And on the right-hand side, we see the model migrated to ERWin with the packages imported as ERWin subject areas. So ERWin imports the packages in the native PowerDesigner file as a subject area. Now, ERWin subject areas don't have a hierarchy, so we just see a flat list of loan subject areas. And all FIB-DM entities are at the model level, not within the packages. So here under entities, this is where we see a list of 3,200 individual entities. And the reason for that is that some data modeling tool imports require a flat list. So when I tried it with entities within the packages, the import couldn't process it. So to make it easy for everyone, entities are in a flat list underneath the model. However, you can copy entities into PowerDesigner packages or into ERWin subject areas. No, that's very easy. You switch to physical names, search card account entities. No, they all start with the same prefix, and then copy them into the cards package or subject area. Yeah, every new FIB-DM quarterly release has package entity diagrams of the new FIBO editions. So here, for example, the diagram shows all entities in the guarantee package. And the FIBO has the package under finance, business and commerce, no, a higher level module, not under loan, because guarantees are also used for fixed income securities. So that shared content here between FIBO securities and FIBO loans. And then there is a diagramming convention. We have a stamp that shows the model, package, diagram name, author, copyright and date, and also the FIB-DM and the FIBO version. Now, base entities are in yellow. That's a general FIB-DM diagram notation convention. And associative entities are in blue. And I recommend to use this coloring for your extension, because it makes it fairly easy to read the design. Relationship names have the connected entities delimited by a hyphen. So here we see the relationship name, issues dash letter of credit. Now, issues is the association, and letter of credit is a base entity. And also the very important is there is a stereotype that's parent or child. And this is what we usually as data modelers see in a relationship as well. No? So this one here, we read it as issuer issues a letter of credit. And now the cardinalities on the associative entity, it's generally 1 or 0 too many. And on the base entity, typically it's optional 1 or 0, unless the source ontology specifies a minimum or exact cardinality. No, so whenever you see a mandatory relationship, that means there is some class constraint that got transformed into a cardinality. Yeah, package properties. Here we have the mortgages packages, FIBO, loan, ERWin, MTG. And we see here the package name is the rightmost string in the ontology namespace. And code transforms the prefix into a package Unicode. And all ontology classes properties with the prefix FIBO, loan, ERWin, MTG become objects in the model package. So in other words, all mortgage entities have their code starting with FIBO, loan, ERWin, MTG. And the URI is the uniform resource identifier of the ontology. And this is a hot link. No? You have the traceability, you can click on it, and you are in the FIBO. And the package properties box has 3 tabs: annotations, lineage, and extended attributes. Package annotations, they derive from ontology annotation properties. And they get transformed into PowerDesigner Extended Attributes, or in ERWin you find them as user-defined properties. And here, for example, we have the package property annotation for OMG Commons roles and compositions, and the tab shows populated the most common package annotations. So only some packages will have certain annotations. Now, for example, OMG Commons roles and composition show the label, contributors, and the node, but for roles and compositions, annotations like file name, see also, depends on, are not documented. No, they're not needed, but some other packages may have a particular package annotation. So the package lineage tab shows transformation and FIBO properties, not as opposed to documentation items. And here for the same rules and compositions package, we see the resource name, and that is simply the ontology prefix. And the resource type is in this case an all ontology, and on entities, resource types may be data property, object property, or class. And the abstract is a brief description in some ontologies. No? So again, OMG Commons defines an abstract, and that is what we use for a package comment or definition. And then copyright and license notes are copied from the original source ontology, and with that FIB-DM fulfills an OMG and FIBO MIT license requirement. No? And if you have the FIB-DM commercial license here, your license is the JZ Intellectual Property License Agreement, the IPLA. If you have the open source version, it's GPL 3.0. So an important, just like FIB-DM does it with the FIBO source, ensure that your derived work retains the JZ, OMG, EDMC copyright and license notes. Yeah, the package and extended attributes tab, that's just a PowerDesigner generated tab that lists all extended attributes on the package. And there is a complete list of the ontology annotation properties. And after migration into other data modeling tools, the ontology annotation may show in a tool-specific representation. Now, for example, in ERWin, you would have a tab with a list of the user-defined properties. Entity properties. So the name is the ontology class local name. And that's a simple camel case to logical data modeling naming convention. So we have the first letter in a word capitalized, and we have a space between the words. And the code transforms from the ontology class. It is the prefix, a colon, and the local name. The comment populates from class annotations that the RDFS comment or the SCOS definitions. So the FIBO uses either of the two to document an entity. And then for entities, there are also two more tabs in the PowerDesigner model for annotations and for lineage. Entity annotations. So FIBO classes have extensive documentation. They are captured in ontology annotation properties. So the source, abbreviation, adapted from, definition, explanatory note, all the way down to scope note, they are documented only for some classes. Hence, the text boxes may be blank for most entities. Now, so here in this example, the commercial loans has an explanatory note. Most entities have a synonym, but you don't need for this one here an editorial note or an example. This is important here. Deprecated entity means that the deprecated FIBO class will be removed in future releases. And this is how the FIBO manages refactoring for design changes. So when OMG Commons was incorporated, some of like-named FIBO Foundation entities become deprecated, which means you should use the equivalent class in OMG Commons, not the FIBO Foundation class. And in a future release, these foundation classes disappeared from the model. So in short, if it's deprecated, don't use that entity for your modeling. Use its equivalent entity instead. So defined by defaults to the source ontology, and that is the FIBO code, the package code in FIB-DM. Yeah, RDFS comment or SCOS definition provide the entity comment. And likewise here, labels, you also note editorial scope nodes are only populated for entities where they are applicable. Yeah, the entity lineage tab captures ontology metadata of the source class, and the extended attributes provide traceability into the ontology, and also they preserve semantics beyond the entity relationship model. So these are not plain ontology annotation, but rather information that got captured during the transformation process. So the resource name is a class and local name delimited by a colon. So we use the resource name as the entity code, but you can generate your own codes in the modeling tool. Now the prefix is an abbreviation of the source ontology URI. And the resource type again indicates the type of source object. No? So that can be an OWL class, data type property, object property, or ontology. And the URI, the uniform resource identifier of the class, is a link into the FIBO ontology. Now here, restrictions and equivalent class axioms formulate higher OWL semantics. And they are important business rules for DBAs and for developers. And here, for example, on the commercial loan, we see a class restriction, which means that entity has a borrower, and that is a role played by some legal entity. And now rules like this, we cannot model them in ERWin or PowerDesigner. No? And that is where the ontology has higher semantics in actually formulating these business rules. So what COD does is it processes the class restrictions and derives associations from it. So finding this class restriction, COD creates the association to borrower and to legal entity. And it documents the original class restriction text in the lineage extended attribute. And likewise, individual labels. No? There, you have it for a lot of FIBO classes where there are instances in the source ontology. No? For example, for country codes, for currencies. No? And what COD does is, well, we don't have instances or examples formally in the data model. However, then we list them here at this entity lineage extended attribute. Yeah, and here's a class restrictions limit the set of allowable instances for a class. So here, for example, the obligor must have an obligation to some commitment. And note in the ontology object property has obligations transformed into an associative entity in FIB-DM. And the transformation processes the class restrictions and creates relationships from obligor to the associative entity has obligation. And class restrictions also determine relationship cardinality. So here sum means that the obligor must have at least one obligation. And class restrictions can be very complex. So even the obligor restriction below is beyond entity relationship model expressivity. So the obligor plays a role as a party to some agreement. So FIB-DM does not transform class restrictions, which are anonymous classes, into pseudo-entities. However, FIB-DM preserves these business rules for the benefit of downstream physical modelers and application developers. So here you as a DBA, you can read up the class restriction in the FIB-DM model and instantiate as a check constraint. An ETL developer would check this constraint before populating obligor table records. And application developers also know what are allowable values for a certain entity. And entity equivalent defined classes in OWL specify conditions for their members. So unlike for the primitive class, we don't construct SQL insert equivalent instances into the class. Instead, the inference engine, also known as a reasoner, determines the instances that match the equivalent condition. So here in this example, the FIBO LEI legal entity identifier registered entity is equivalent to OMG Commons is identified by some FIBO legal entity identifier. So FIB-DM has entities transformed from equivalent classes. The equivalent lineage attribute is a physical modeler for the physical modeler to consider a view or alias. Defined classes may have more complex conditions. For example, here a fixed float interest swap has a fixed and a floating leg. And these are important business rules for ETL architects populating a FIB-DM database. Multiple inheritance. Now, an ontology class can be subclass of more than one parent class. For example, here the central bank is both a bank and a monetary authority. And that makes sense from a business perspective. And it makes sense in a conceptual model. And we have it not only in ontologies, but also in UML. You can have multiple inheritance. However, in a data model, in a logical and physical model, we can only have one supertype. So the logical modeler can use some techniques to resolve multiple inheritances in the conceptual data model FIB-DM. And mainly there are two ways. Number one, the issue goes away. So let's say we have our central bank in FIB-DM. It's a subtype of bank and monetary authority. However, when we attribute the model, maybe the monetary authority doesn't have attributes, or it's not in the scope. So in that case, the issue goes away. Now we are only left with one supertype of the central bank. And if both supertypes are valid, in scope, attributed, then in the LDM, the modeler changes the supertype to dependent relationships. No, so here the top conceptual diagram becomes an LDM with both bank and monetary authority providing identifiers that constitute the key of central bank. Entity attributes. Now, FIBO domain ontology is a business conceptual model that defines concepts using class and object properties. So there are only 332 data properties in the source ontology. So therefore, FIB-DM is an entity-level conceptual data model, and it's sparsely attributed, and it doesn't have keys. PowerDesigner CDM has data items. These are model objects independent of the entity. Now, the data item gets attached to the entity as an attribute. Data items as a model object disappear when the modeler derives an LDM to the CDM, from the CDM. So in the LDM, we only see attributes on an entity. And likewise, if we import FIB-DM, the CDM, into ERWin, we will only see entity attributes, no, not data items. Yeah, and then the transformation creates data items from source ontology data properties. The property domain and class restrictions determine attributes on an entity. Associative entities. So CORD transforms ontology object properties into data model associative entities. And the relationships between a base and associative entities are transformed from object property domain range and class restrictions. And here again, the diagram notation in FIB-DM is yellow for base and blue for associative entities. And the stereotype on the relationship line indicates the role, whether it's a parent, a child, or both ways dual. And here in our example, a registrar or registration authority, parent, registers, child, legal entity, or a national securities identifying number. And in most cases, a class restriction on the child entity would tell us which is the parent registering it. And object properties are multi-valued. No? So the associative entities may have relationships with many base entities. And then, as we will see in the logical model, you may convert the class restrictions and restrict the relationship from parent to child. Yeah, associative entities in the FIB-DM have a hierarchy, and that's the reason why they are entities and not mere relationships. And this is an essential OWL construct and widely used in the FIBO. So virtually all FIBO object properties are in hierarchies. The default configuration to transform a domain ontology into an enterprise data model therefore creates subtypes of associative entities derived from the RDFS sub-property of. Now, and here in our case, we have associative entity governs, and their subtypes are govern payment of, supply of, has jurisdiction, or governing jurisdiction. And typically I recommend for an LDM to scope the most specific level, the lowest in the hierarchy. No? So if your base entity apply to a governing jurisdiction, use that associative entity in your scope and not the generic governs parent. Yeah, and then some may look like a star schema, no? So here the context diagram here shows the identified association and some of its participating entities. Now on the left-hand side we have the parents. Now you see the various legal entity identifiers, customer IDs, account IDs, currencies, securities. And on the right-hand side is what is identified: legal persons, customers, accounts, currencies, securities, trades. So it looks like a star schema with a fact table in the center. Now this is fine for a dimensional data model, and the model integrity check in PowerDesigner doesn't complain. But the denormalized design may not be appropriate in an LDM for an operational database. So, however, just like we have seen with multiple inheritance, we prioritize the clarity of the design for business users over third normal form correctness. And then in the logical data model, you would rename relationships. No? So you can role name them, for example, saying identifies a currency. And or you can add a type of identification with value currency identification. No? Yeah, and we can resolve multi-valued associations as we move from the FIB-DM conceptual and derive a logical data model. Now the LDM rule number 1 applies. In your LDM, you attribute with data items from your source system feeds. And then the issue may disappear simply because we remove entities that do not have attributes. And now if you want to control and prevent incorrect entries in an identifies table, then you can follow the normal data modeling pattern. No? You can create a selector type, and you can create subtypes that narrow down the allowable values and relations. So here, for instance, we can say we can create a subtype identifies bank with a parent bank identifier and the child bank. And we can actually look up the class restriction on the entity lineage tab. No? So there's a restriction bank identifier identifies bank. And we can create the subtype if we want to control the values and prevent data integrity issues. And the physical modeler can decide to roll up or down the identifies subtypes. But as I said before, FIB-DM does not prescribe how the data modeler resolves the design in the LDM. No, so FIB-DM is 100% FIBO, nothing added, and you as a logical and physical modeler decide how you instantiate FIB-DM. Relationships. So FIB-DM uses associative entities to model ontology object properties. And therefore, relationship model objects are merely connecting base entities to associative entities. And they transform from the object property domain, range, and class restriction. And the naming convention in FIB-DM is simple parent entity dash child entity. No? For here, for example, we have the FIBO foundation accounts currency identifier, and identifies is the CMS identifies associative entity. And likewise, the relationship name and comment are generated per the code configuration settings. And the stereotype indicates the relationship role. And one specialty, only associative entities. They derive from like name class restriction only. Associative entity limits the participating base entities. So for example, OMG Commons has member object property has numerous related classes. No, however, organization has a class restriction. Commons has member only applies to a party. In other words, only a party, nothing else can be a member of an organization. And FIB-DM models the business rule by creating a subtype of has member with only organization and party as related base entities. So here we see the associative entity has member in Commons, and FIB-DM has organization only has member as a subtype, and that has organization as a parent and the party as a child. And this concludes the structural overview. Yeah, this concludes our FIB-DM deep dive, and here are some resources for your further study. So diagrams of the data model are in your delivery zip folder. And they are also published on the FIB-DM website, and there are over 50 diagrams. And to be clear, not all diagrams are in the quarterly FIB-DM releases, simply because the model file would become too big for import and for handling even on a PowerPC. So typically the FIB-DM release has maybe a dozen diagrams, the newest for new ontology modules, but not all of them. No? So here this keeps the history, and you would do the same if you adopt FIB-DM and customize it as an enterprise data model. So open source users can review this PowerPoint in MS Office online and also download the PDF. And if you have the full model version, then you find the original PowerPoint file in your delivery folder. And you should study the articles for deeper understanding of hierarchies and associative entities. And you can watch the next lesson on the YouTube course, which is about scoping a submodel from FIB-DM. Yeah, thank you for attending this